All righty, it's so nice to see everybody who's joined in here early. We're gonna start in a couple more minutes. Just wait with us while others join in. But we want to appreciate your time, and we appreciate the guys who have joined in right on the dot. But we will be starting the webinar shortly in a couple more minutes. All right, great. Good morning, good evening, good afternoon to everybody joining us from different parts of the world. My name is Dinaka and I'll be the host for today. And I'd like to take this time to welcome you to Pcloudy's webinar on mastering test orchestration. Learn how AI agents reduce the execution time by 70% and improve your reliability. So before we get started, I would like to go over a few housekeeping rules. You may have noticed that your line is currently muted. And if you have any questions, you can submit your questions during the webinar using the Q&A option that is available. We will answer your questions as part of the Q&A section at the end of the webinar. So please do keep those questions coming in. We'd love for it to be very interactive. And also please do note that this webinar is being recorded and we will shoot out the recording, the link of the recording to share with your colleagues later or to watch it a second time. With that said, let me introduce the speaker for today. We've got Jessica Selvin. Jessica is a test evangelist at Pcloudy. She has around 5 years of experience in the IT industry. And prior to her role at Pcloudy, she's been working with LTI Mindtree as a pre-sales consultant. She was doing this in the automation solution domain for various different industries. And she has a keen expertise in data analytics and various automation tools. So without further ado, let me hand it to our speaker for today, Jessica Selvin. Over to you.
Yeah, thank you, Dinakar, for that introduction. As Dinakar has already highlighted, today we will be talking about test orchestration and how orchestration can bring about reduction in your execution time by 70%, improving the stability, reliability, and efficiency of your test suites, right? So with that, let me get started. Yeah. So firstly, let's take a step back and look at the reality of today's QA world, right? Let's see where we face the hiccups and what are the new trends that are arising. Firstly, we see that there are much shorter release cycles now, right? So our time budget for quality is collapsing. So when you ship features so quickly, maybe weekly or daily, there isn't room to run a 10-hour regression or wait overnight to learn what are the critical flows that broke, right? Modern CI/CD means that every commit is potentially releasable, so tests have to provide the signals immediately. So that pressure exposes every inefficiency in the way we schedule and execute tests. Secondly, we are having and starting to have massive test suites. So as products mature, we don't just add a handful of tests, we add hundreds, maybe thousands, and then multiply them by the devices combinations or the OS versions or the browser versions, right? Right. So adding 800 test cases, for example, across 5 devices and different OS versions, say 4 OS versions, just think of the permutations and combinations that would involve, and running everything everywhere at every time is no longer realistic. Thirdly, because of these, there are shorter feedback loops now, right? Even with a device cloud and plenty of CI runners, work piles up and jobs are waiting in queues. And there's network latency between your code and remote infrastructure, right? And finally, because of this, there is rising test flakiness, right? Some of it could be code related, maybe timing issues or stale locators, but a lot could also be environmental, right? So there could be network jitters, a shared state between parallel jobs, devices that aren't isolated well. And over parallelization can actually make things worse, where everything finishes except maybe a few which needs to be retried or rerun, right? So there's a lot of rerun culture and spend time, the engineering time, looking into whether a red build is either a real regression, I mean, real issue or just noise, right? So all these are some of the realities as QA you would be able to, you'll be able to go ahead and relate to that. So with that said, let me just go ahead and get into what are the ways that testing is evolving fast, right? And we see that test automation or scripting is evolving fast with AI, but test efficiency is still not yet on par with AI, meaning test execution. So AI has trained us to expect answers instantly, and engineering mirrors that with smaller PRs, rapid mergers, right? Yet our test cycles are taking hours, right? And even if the tests themselves are quick, there could be other latencies that add up and make your test cycles much longer. Even in terms of the infrastructure and signal quality gap, right? So the real failures versus flakiness. So as we parallelize more, as we're running on more unstable environments that might be introducing network latency, we see more environment-induced flakiness, right? Timing issues, resource contention, network jitter, and test data collisions, right? So the signal to noise ratio drops precisely when the organization needs faster, clearer answers, right? So we are seeing that in the test automation scripting space, but we are not yet there when it comes to the test execution. So with that, let's see how in the overall history of how test automation has evolved and how QA has evolved, right? Where does intelligent test orchestration fit in, right? So firstly, talking about manual testing with spreadsheet reporting, right? Early practices that mainly relied on human execution of checklists, collation of results on spreadsheets, um, you know, uh, so this model was delivering slow, inconsistent feedback, limited traceability. And next was the waterfall methodology that formalized the stages and sign-offs. It introduced more predictability, but at the cost of agility. It was testing still remained a late life cycle activity, and any change in late in the process created substantial rework and schedule risk, right? Then came the automation phase with frameworks like Selenium and APM, right, which codified repetitive text, reduced manual efforts. However, execution still remained largely static, right? Full suites were triggered on fixed schedules or broader events, and regardless of what had actually changed in the code base or environment. So there was no intelligence in the process. Basically, right? Your test suite was just scheduled at fixed points in time, and as and when there was a release, it was triggered, right? At the same time, agile continuous testing and DevOps comes into play, right? With pipelines began to run tests on each commit and against every device, browser clouds. So the velocity in terms of the releases increased, but the newer constraints from the execution standpoint started coming out, right? Very large suites, right? Contention for shared infrastructure, rising flakiness. So feedback often arrived too late, because as and when features are getting shipped, the feedback is not coming in as quickly, right? And finally, in the phase 5, we see the AI-driven test orchestration. So this is where we are at, and this is the current inflection point, right? It's no longer more and more scripts, but better decisions about our execution. So intelligent orchestration treats testing as a continuous observe, decide, and act loop, right? So be it observing the code patterns or recent code changes, historical failure patterns, right, and deciding based on that to prioritize what kind of test cases are likely to yield a more meaningful signal, right? And finally acting on those, right? Execute close to the target infrastructure to reduce latency. So parallelize safely at scale and apply to targeted retries instead of everything being retried or your entire regression suite for a particular code change, right? So organizations adopting intelligent orchestration realize three consistent benefits. So firstly, faster and earlier signals. Instead of waiting for hours before you get the feedback, actionable results are much faster in minutes rather than hours, right? Higher signal quality. So because of the reduced flakiness or the false negatives, right? Reduced noise from the environmental flakiness or network related issues, right? Or queuing issues or parallelization issues. These are all limited and we are able to have a clearer pass and fail semantic. And finally, improved overall utilization and in terms of even efficiency in terms of economics, right? Higher utilization of your existing resources, be it your infrastructure, the device browser infrastructure, and higher utilization of your current capacity and fewer redundant executions, right? So AI orchestration in terms of execution is here to stay, and it will be one of the crucial components and will lead the way in autonomous testing. So that's for sure. So let's just take a step back and see a particular workflow on how currently uh, your scripts, why they're taking time to send and receive requests from your test cases, right? So let's take a typical flow of you are running your scripts, be it from your framework or from your CI/CD, you've triggered it, and now you're running it on a device cloud platform, and then you're waiting for your results, right? So um, what are the different points, and what is the path that your script would travel and for you to get back your feedback, right? So firstly is the script that you may be executing from your laptop, your CI runner, right? And that talks to the provider hub, which is basically the web driver or your APM endpoint, APM Selenium endpoint, right? So what are the challenges here that for each and every click action, right? Be it if you're familiar with APM or Selenium, right? Like find element or click or get text. Everything sends a tiny HTTP call to the hub, and this is passed over the public internet, right? So which itself introduces unpredictability and latency into your system. So, for example, imagine that there is a latency tax on every call, right? And even if it's on a small scale, it might look like a very minute difference, like in maybe every call introduces 250 milliseconds of delay per round trip, right? But if you multiply that by 100 commands or even 1,000 commands, it will be 25 seconds or 250 seconds, right? So that will add, and if that's per test case, if that is the latency getting added, and if you're executing hundreds of thousands of test cases, you can imagine the kind of latency that will happen, right? So multiply this by dozens of tests, and that's where you will see the hours getting added into your test cycle. Next is the hub or the browser device node, right? So the hub forwards each command to the worker running on the browser or device. So for a new session, the node may boot a browser, and there could be some predictabilities in terms of having the right device availability at that point in time when the request is placed. So cold starts will be adding 6 seconds to every job, and right, so the queuing will start, right, and this will also be adding to additional time for your test cycle to finish. So, and also from the artifacts that need to get received back, right? So be it for our test reporting, you will be collecting maybe the session video or the screenshots or the device logs. So all of this, page loads, API calls, all of this will add variability again and can impact the test cycle time. So that is to do with the network jitters or dynamic content. And as I mentioned, right, where WebDriver or APM is request heavy by design, right? So because every single request, it's very request heavy. So every single action step places a separate HTTP request. So this getting added into every single test case is where your primary latency is coming. So that's where you would see the teams would start feeling the pain, right? Because of these systemic challenges. The distance and the chattiness or the request heaviness that dominate the time. So many tiny calls over a long distance will eventually lead to a big overhead, right? So the browser click may seem fast, but the round trip to get that feedback is not. And suits often are split by test count and not duration. So this also can lead to queuing. And finally, environmental flakiness and reruns. So there could be some intermittent reds or false reds. Teams normalize rerunning to get, which inflates the cycle time and hides the real regressions or the real issues, right? And finally, observability gaps. So getting the artifacts and logs, these are fragmented, then this will be coming in as a bulk. So this will also add latency into the system, right? Like a thing like session video, fetching the session video or the screenshots, right? So all these are part of every typical in a traditional way of doing test execution. These are the different challenges that come into play, which may not be visible directly to you as the QA, but this is what is causing those lags and increased test time cycles for you. So to summarize, what are the different aspects which are causing this is firstly, as I've already highlighted, is the network. Every single call has to travel back and forth. Also, screenshots and videos also have to take the same path. So this leads to the network latency, test flakiness because of the environment, right, and network jitters. So maybe a network locator has changed, or the wait time wasn't long enough, right? So these kind of things can introduce flakiness to your tests, which need to be rerun again and again. CI/CD pipelines also can look simple, but when we're running on a huger scale, right, one slow chunk can hold up the entire run, right? So, and then gathering test data, as well as finally, just to summarize, four things that are slowing down is that the internet isn't always fast, and the tests sometimes fail randomly, and pipelines aren't perfectly balanced. So all these add little delay, and together they add up to become a huge delay, right? And that's why you would be feeling that the feedback is very slow, even though when the individual steps may seem quick. So what are the key factors that are needed for you to have modern AI-driven test execution, right? That speeds up at scale, right? Let's look at some of the factors in that. So firstly, aligning with rapid release cycles, right? So we need feedback while, because as and when the features are developed from the development team, the feedback to the development team must be faster, right? And that means shrinking up the round trip delays and getting early pass or fail on the highest risk areas first. Secondly, handling growing test suites. So suites grow, but so does the device browser matrix. So running everything and everywhere won't scale. We need, what is required is more of a smart distribution that splits the long tests and runs safe parallel tests, right, that do not slow down your entire test cycle time. And finally, prioritize test by risk. Not every change would be requiring a regression, right? So we should pick tests that are most likely to catch a regression based on the code that has changed. So usage patterns or failure history, and that turns it into a signal and not just a simple execution. And finally, eliminating your test flakiness and instability. So random reds would drain the reliability of your test results, right? So we need separate real bugs from the noise and isolate flaky tests, apply targeted retries and not simply retry every failed test, right? Only where the history suggests flakiness, and fix the root causes. And finally, optimize cost and efficiency. So we need higher utilization of the grid or the resources of your test infrastructure that you are already having, right? So fewer redundant runs and smarter placement, so finish faster without inflating the speed. So putting together, what are some of the, so running sooner, getting the PR feedback windows, running smarter with risk-based selection, running cleaner with less flaky tests and clearer results, and running with better utilization with fewer redundant executions. So these are some of the key factors you can say that would play a critical role in ensuring that your test execution is running in an optimal way. So yeah, so to reiterate the point, traditional automation isn't enough, and with these factors, test orchestration with intelligence will be the missing piece, right? So ensuring that you have that in place along with intelligence for your automation script development, having intelligence and orchestration in your execution as well is the missing piece to ensure higher efficiency. So with that, introducing Pcloudy's QuantumRun, which is Pcloudy's intelligent orchestration engine that executes your existing tests next to the device grid and actively schedules them across real-time capacity, right? So the two biggest time sinks that we were discussing, right? The network round trips and the backlogs are effectively engineered out of the loop. So that is what QuantumRun will do for you, and will power up much faster, scaling up your test execution anywhere between 10 to 10,000 runs it is able to handle, and it executes them next to the grid so that it eliminates those network latencies. So what are some of the key capabilities of QuantumRun? Like, as I mentioned, 70% faster test execution. This is something we have observed directly from running typically versus running with QRun. We have observed 70% on average faster test executions. So this comes from changing the topology of the execution, right? Not just pushing harder on the grid, but QRun packages your suite and runs it next to the devices and browsers. So it is not taking the requests over the public internet. This is next to the device browser grid, and that removes the WAN round trips, right? So thousands of fine-grained, each and every API call that you see is now not traveling over the public internet, but over the low latency internal links. So this results in dramatic time cuts, right? So you are able to see, as I mentioned, 70% faster executions. Next is lightweight programming. So there's no need to make any major changes to your current test scripts, right? So there's no need to rewrite anything. There is no new test framework as such. You can keep your APM Selenium script as well as your CI. All you need is to zip your project, create a job or a project, set the targets, and run. So QRun will be able to handle the session, drivers, placements, and the retries, as well as giving you the final output results, monitoring your sessions through live view. All of that are in place, right? So there is no major changes required to any of your scripts in order to make your QuantumRun work. Thirdly, faster feedback loops. Because of the network latency being heavily reduced, you will be able to get those faster feedback loops, and you will get the faster first signal much faster, right? So this will, in terms of tracking it from your first pull request to the first result time, will be much faster. And QRun is designed to pull that number down and keep it stable even as your test suites are growing. And also, this would reduce your test flakiness, and because of targeted and capped retries that isolate the suspected flaky tests, so they don't clog the main queue, and you're having consistent, results. So with fewer reruns, clearer failures, and a build status you can trust, right? So that is where QRun will help you, be it in terms of your faster execution, faster feedback loops, and reduced flakiness with minimal change to your code, right? So that is where we are talking about the key capabilities of QuantumRun. So let's deep dive into some of the key tech behind QuantumRun, right? So I'm just going to highlight on 4 key aspects of QuantumRun. Firstly, the proximity execution. So as I mentioned, right, the first row that you see, the first image, right, in a straight line, you have the script, hub, browser, and your testing app, be it your mobile app or your web app, right? So that is where the latency is introduced because it goes over the public internet. Whereas here you see that all your key components are placed next to your device infrastructure, right? So every tiny web driver or APM command that makes that full round trip over the internet, right? All that is going to be now happening over a low latency call with the device infrastructure within the same network, right? So there is no network hops, and there is no travel over the public internet. So that is where you're getting the major latency reductions. So when you're implementing that to the thousands of test cases, right? That is where you're going to see those major benefits in the time cycle reduction. So Yeah, let me just get deep dive into some of the key aspects of this. So firstly, the artifacts, right? Your screenshots, videos, logs are captured beside the run. So everything is streamed out efficiently because it is not competing over the command traffic, right? And this leads to latency collapse. Next, the queues are shrinking with faster per command execution, right? Because of that time reduction and the proximity execution, the device time is freed quickly. So the devices are getting freer quickly and the capacity increases, right? So as and when the test cases are executing faster, the devices are getting freed up for your other test cases to run, right? And this is improving your stability because of the fewer internet hops, which means there are fewer timeouts, fewer retries, fewer false negatives, right? And also security and simplicity, right? So there is no fragile tunnels from your CI to devices, right? And so the final takeaway is that what proximity execution does is it flips the topology. It moves your test scripts to the devices where the execution is actually happening, right? Instead of having communication one by one for each call over the internet. So this eliminates most of the network latency, it reduces the queuing, and you get faster, cleaner signal without changing or doing anything different to your scripts. Next is the high performance runtime. So QRun is built on the Go language, right? So that choice was intentional because it really makes the engine quick, steady, and easy to scale. So you're able to do lots of things at once. Golang gives us tiny, lightweight workers, right, where you can run thousands of these at the same time. It helps in parallelization and finishing together, right? And secondly, it starts fast. It compiles into a small single binary, right? And the containers are light and boots up in seconds. Thirdly, smooth logs or video streaming, right? So it handles the input and output very well, and it's able to get these heavy data, right? Like your video sessions steadily while the test cases are running. So it doesn't jam the pipeline or slow down the test. It's also stable under load. So this will really help you scale up. So even if you're starting small and then you're planning to scale up with your test suites, it is able to handle that. And so the bottom line is that it is highly lean and concurrent, right? So, and that makes QRun to come up fast and the performance stays steady even when the system is busy, right? So the building on Golang was an intentional decision in order to achieve better efficiency as well as better queuing, parallelization, and stability under load. Yeah. Another feature of the tech behind QuantumRun is that you're able to have parallel distribution. So QRun breaks the suites into tasks and uses the history to estimate the duration, right? So long and short test cases are mixed to create a balance. And there is containerized execution. So each task runs on an ephemeral containerization container with just the tools it needs, right? So you don't need to worry about scaling up, right? And there's smarter placement. The scheduler looks at the live capacity, which devices and browsers are free at that point in time, and places the tasks where they will finish faster. So, and also it is able to have failure isolation. So if a device disconnects or a browser crashes, only that single container is retried and it does not impact the entire job, right? So suspected flaky tests will get a cap retry in isolation so that it doesn't affect the other test runs that are happening. So that is, a quick overview on the parallel distribution. Next, we have intelligent orchestration, right? So it is able to analyze the code changes, the historical failure history, right? Test duration, live device browser availability, right? And it's able to decide based on a risk-based prioritization, right? It's able to score tests by the likelihood and impact, and it doesn't just simply rerun every single failed test, right? So if a test fails, it will classify it and see whether it's a suspected flake, and then a small isolated retry is done. And finally, execute near the device grid, right? So it is able to execute your test cases, and it's bringing it to the device grid where your actual devices and browsers are running. So this will help to rebalance if the capacity shifts, and early failures will be immediately detected. So this is what intelligent orchestration will bring about, right? Instead of running everything, it is able to smartly schedule, smartly allocate capacity, and do the risk-based prioritization. So to summarize, where are we seeing the key differences with the traditional approach versus QuantumRun, right? So firstly, you're able to see that the remote execution that is added latency is reduced by bringing local-like near grid execution. So the typical challenge of, because I'm executing on cloud devices, there is more latency, will be eliminated, right? And that is bringing it up to 70% faster. And also the network-driven flakiness, which isolated workers and devices that are yielding consistent results. And instead of running everything, the AI selects only the tests that matter, and based on prioritization, based on history, it is able to make those calls, right? Faster feedback, right? So real-time actionable signals are there while developers are still having the context. So as and when the features are released, around the same time you're getting the feedback on that, instead of there being a delay or a lag in terms of the collaboration between QA and dev, right? So finally, where QA is becoming a bottleneck, QA becomes a accelerator where you're giving faster feedback to the developers, and your failures and passes are trusted, right? So traditional execution, you are paying latency and a queue tax. QuantumRun removes that. The distance schedules intelligently, and it surfaces the signals much faster. So QA stops blocking and starts accelerating. So that is where you would be seeing the differences with QRun coming into the picture. So with that, before we move into the demo, I just want to give a highlight about our entire product stack and see where QRun would fit into that, right? So I'm just going to talk about our entire Pcloudy platform architecture here. So firstly, you see that we have our test infrastructure where we are hosting real devices and browsers, and we also support customized devices. And we have our autonomous orchestration, right? This is where our QRun comes into play, and it's able to execute your test cases much faster with, eliminating the latency, prioritization, and intelligent parallelization. And we also have several AI agents that are present. So we have our test case generation agent, we have a test script creation agent. So all these AI agents, especially when it comes to script creation, you will be able to accelerate from the test creation side, and QRun is able to accelerate from the test execution side, right? And some other agents to highlight is that we have an observability agent that will give you AI ML insights into the performance of your application. We have monitoring agents that will monitor and run 24/7 critical workflows in your application. We have even agent builders and AI systems testing agents as well. So that is just to give you an overall idea of our platform, be it functional testing, performance experience testing, as well as our core device infrastructure of devices and browsers. So QRun will be a critical component in ensuring that you're able to scale that up and you're able to scale your test cases and test suite executions. So with that, I will move to a quick demo of QRun and show you how it works. Yeah. So this is our platform. This is our Pcloudy platform. We're a SaaS-based platform, and I'm demonstrating this on our public cloud, though we have several modes of deployment, be it on-prem or private cloud options as well. So as I mentioned, we have our real devices and browser infrastructure here, where you will be able to see that we are hosting actual physical devices across our multiple Pcloudy data centers, right? So we have devices across different geographies and regions. So every device that you see here are real physical devices, right? And you can, to give you an idea of the range, we ensure that we have the latest OS versions on onto our platform, be it Android 16 and 15, and we also support the earlier versions. Similarly for iOS as well, iOS 26 and 18.5, along with the earlier versions of iOS, and all the different OEMs like your Apple, Google, Samsung, and so on. We also have SIM card enabled devices to do test your push notifications, OTP, SMS based scenarios as well. And as I mentioned, we have multiple data centers across India, the US, Singapore, UAE, and a few more in the pipeline as well in Canada and the UK. So that is just to give you an idea about our mobile device infrastructure. And similarly, we have our infrastructure in for Windows and Mac machines for your cross-browser testing as well. So we have Windows and Mac machines, and we support all the different versions as well for your browsers. So for example, for Google or Firefox, Edge, Safari, right, we will be able to select the versions and go ahead and do your cross-browser testing as well. So that is a bit to give you an idea on our device browser infrastructure. Along with here are some of our agents, right, like our test creation agent and our performance experience agent. And today I will be deep diving into our QRun. So let's just have a look at that. So firstly, you can go ahead and create a project of your choice, right? Like for example, for a new application or new build, you can go ahead and create a project, give a project name and enter the description and save it, right? So I'm already having a project here. So once you've created the project, you can go ahead and create a job under that, right? So this is what will help containerize, as I mentioned in during the session, right? This is what will help containerize your test suite separately and ensure that it's not affected by other test execution. So you can go ahead and create a job. So let's do that. So you can go ahead and give a name to your project, sorry, a name to your job, give a description, and select the automation framework that your test cases are written in, the language, and the framework, right? So once you have selected that, you can go ahead and upload the zip file of your project. So be it wherever your test cases are, right, getting developed, you can just export it as a zip file and go ahead and upload it, right? So there are no major changes as such to be done to your code. So I'm just going to go ahead and select a project here. Once selected, I'm going ahead and saving this job. So you can see that the job has been created successfully. Now I will come here and go ahead and trigger the run. So you can see here that I'm going to create the run, and I can go ahead and monitor it over here. So there's this unique run ID created for that, and this would be running containerized, right? So as and when it gets picked up, so firstly, what will happen is there is going to be it's going to go ahead and download the zip file and ensure that the zip file is, your scripts are running locally near the devices. So that is what is happening right now to ensure that, you need to ensure that the network latency is minimized, right? So that is why we're uploading the test cases as a zip file to ensure that the test cases can be retrieved and placed near the devices so that those network latencies are minimized. So that is happening now, and the tasks are both in progress. So here, for the purpose of the demo, I'm just showing a couple of test cases. Of course, QRun can scale anywhere between 10 to 10,000 test cases, and you can go ahead and sign up for a trial if you want to try it out as well. So meanwhile, as and when the tasks are getting picked up, right, another thing you can go ahead and do is monitor your active sessions. So any session, be it a manual or an automation session, will get reflected here. Yeah, so you can see, right, there is a couple of devices are already picked up and it's ongoing. So let's open that up and see the live view of the execution. So the devices, so one task is already completed here, you can see, and there is another one ongoing. Meanwhile, you can also track it from your reporting, right? So if you don't want to open up the live views for every single execution, our live reporting is already there, so you don't need to wait for the execution to finish, right? So that is where you will be seeing, faster feedbacks are happening here, where even before the execution is finished, every single run will have the PR report or the progressive report generated. So you can see here, this is my QRun project that we've just now run it on. And you'll be able to see the status. So I can currently see that one of my test cases are still in progress. Another one that we've just now, it's been updated about a minute ago, has already completed. And you can see the execution live here, the session recording here, immediately fetched and retrieved. And you can also see the text logs, and which is the output of each and every step over here, right? And what the entire suite will help you see is the status of all your test cases. So I can see the failures, I can see what have been completed and how many are in progress. So now even the other test case has also been completed successfully. So I can see the status of that as well. So that has been just updated around 25 seconds ago, and you can go ahead and see the entire results over here, right? So this is how you'll be able to see instant reporting. And imagine scaling this up, as in when you want to scale it up to hundreds of test cases, you will really be able to see that 70% reduction compared to a typical traditional way of executing, right? So that is where you will, as in when you scale up, you will be able to see those time differences much more concretely in terms of the latency reductions and the time reductions, right? So also another few features I wanted to highlight is that you can go ahead and share these links. So you don't need to be a Pcloudy registered user in order to view these reports. So anyone else in the team, right, any other stakeholders who need to visualize these reports, you can just share it. They'll be able to view the reports. You can go ahead and download, the video, the logs and everything, right? And also logging bugs, right? So you can directly log it here from Pcloudy platform itself into Jira, and we have integration with several other bug tracking tools as well. So you can simply configure it. It's just a one-time configuration where you give your credentials, and then you'll be able to log bugs into Jira as well. So that is how you'll be able to track based with our live view and reporting, and how uploading your test cases and creating a job containerizes your test execution, and you're able to monitor it effectively. Finally, coming to the logs here, right, to our QRun dashboard, you'll be able to see the logs. These are the Maven logs, and you'll be able to see the status, right? And you can search anywhere in these logs if you want to, if there was in case any errors or failures. For example, here you can see the success of the test case also marked over here. And similarly, you'll be able to see the Maven logs for every test run, right? So I hope this gives you an understanding and a bit of insight into how QRun works. And I hope this session was insightful for you. So with that, we can go ahead and take any questions that you may have or any other queries. I'm happy to get into the questions.
I've got some here. Let me just share that with you. So one of the questions that I've kind of got something here is how does local first execution reduce latency compared to traditional automation? I mean, you've kind of explained this, I think, a little more
Yeah.
depth.
Yeah. So to put it very simply, right, your typical executions, every single step in your APM flow, right, would involve a separate call being made, right? So for example, if I'm just opening a sample test case, you can see that every single step that you see here, right? For example, every click, every entry, right? Get text, right? Every single step that you see here would involve uh, a separate call or a HTTP call made over the public internet. Now, what QRun eliminates is that you're able to bring all of those test cases into, the place where our devices are posted, right? So we are bringing it, we use specific storage where you are able to download it into our data center location near the devices. So this will eliminate, the network latency, right? And every call is not being placed over the public internet, but internal, high-speed links instead. So that is how the latency is eliminated.
I think another follow-up question, what makes QRun's orchestration different from simply scheduling the tests in Jenkins or similar tools?
Yeah. So even when you're having Jenkins or any other tools, right? What is still missing, the missing element is still that latency, right? So that is where QRun will really create that impact, right? Because the scripts are coming where the execution is happening, right? So even if you're having, you're scheduling it via your CI/CD and things like that, those optimizations will be there, yes, but at the same time, the network latency, right? Those will not get eliminated, right? So that's where QRun will be different, will bring that differentiating value. Yes.
Sorry, I was speaking on mute. Here's another question. Can we try this on one suite before moving everything?
Yeah. I mean, as in when you want to scale up, as I said, right, scaling up is very easy in with QRun, and you can go ahead and start with a single test suite, see how it's working, what kind of results you're seeing with that, and then you can go ahead and scale it. So there's nothing, as I mentioned, there's no major changes to be done to your code in the first place, right? So it's not that you need to make any major changes as such. It's simply a matter of exporting your test cases into a zip file, and then you're good to go.
Okay, there are a few around MCP as well. Um, automation. Okay, will it connect to MCP, or how does the automation runs when devices are chosen?
Right. How the when devices are chosen? Okay, I see those as two separate questions. With MCP, yes, we can do that. If you want to trigger certain runs from MCP, I think that should be possible. I might need to check a bit on the feasibility, but I don't see any challenges there because we already have MCP. And if you check out our previous webinar, we are able to give prompts from your AI, right, like Cursor or Claude, and you're able to see, an execution happening on Pcloudy. So that should be possible. Secondly, how the devices are selected, it's basically you can specify that in the scripts, right? You can give the specific device name, or you can go ahead and just mention the manufacturer, like Samsung, Google, and it'll pick any available Samsung device at that time. Or you can also specify any the manufacturer as well as the OS version, like maybe Android 15 or Android 16, 14, right? And it will pick any one of those available devices.
Interesting. There's another one by Pavan. It says,
Yeah.
can we use this tool for API testing?
Currently, no, we do not have a facility for API testing, but yeah, it is there in our pipelines, and yeah, we will be bringing that as well. But currently, we do not support API testing.
Hey, somebody is curious about how is this different from test trigger and lambda test and so many other competitors that are out there. How is it different? Is one of the questions that somebody is asking here.
Yeah, I mean, in some ways you can say it is similar, but yeah, not a lot of cloud platforms are having, orchestration agents. They support, say, just simple traditional execution, right? So that is where we are actually changing where the network hops itself, right? So other things may be claiming just in terms of other optimizations, be it self-healing, maintenance, or things like that, but where we are also having self-healing, but uh, But here, where you're reducing the flakiness and the time is by actually eliminating the network latency itself, right? So that is one of the key differentiating features when it comes to QRAM.
I mean, I've got a few more questions from Sangana itself. Uh, but I think they want to do a deep dive and understand. I think we can take those questions offline. One of the questions was what AI agent is used in Pcloudy. I know you've kind of mentioned it through when you were talking about the product stack, but maybe just like to throw some light and maybe we can connect offline as well to
Yeah,
understand.
sure, sure. Yeah. So I think you're referring to QPilot, which is our test creation agent. Right, it runs on enterprise LLMs, and you'll be able to give an English language description of your test scenario, and it will generate the script. So we have a lot of content, right, and demo videos. We'll be happy to share, and we can connect to you offline as well, and give you a quick demo. And if you're interested in a free trial as well, we can see how to facilitate that as well.
Great. I think we'll just do one more question and then I think we can wrap up. Um,
Sure.
how does it pick the right devices, OS version, or can I pick a specific model or a browser version?
Yes, yes, you can. You can specify up to the specific device that you wanted to run on, right? It's not even in case if you wanted to run on a very specific device, you can. So Pcloudy, all the devices that we have a unique name, and we do provide that. You can go ahead and see the unique device names in our capability section here. So you simply need to just select the the unique device name, and then you can add it to your script and it will go ahead and run it on that particular device. So you can, this is our capability configurator, which will generate where you'll be able to see those unique device names, right? So if you see here, I can come here and I can go ahead and select any particular device of my choice, and I can go ahead and execute it on that. Now, in case if you don't want it on any specific device, I can go ahead and just specify the manufacturer or the OS version. So that control is definitely with you, and you can optimize however you see fit.
Great. I think yeah, there are a few more questions but we'll take them offline since we want to respect
Sure.
everybody's time. So thank you so much. Thank you, Jessica, for sharing those valuable insights around AI orchestration. And I know your presentation has covered a lot of practical strategies that people can think through and implement and discuss, come back to us. So thank you so much. We also want to thank each one of our participants who have joined in and spared time during the day. I'm sure some of the strategies that were shared during this webinar has sparked a few ideas. Maybe you can take them back, have discussions with your teams, and get back to us if you have any questions. We're more than happy to kind of help you out with the journey. You can reach out to us through our website. We have a little chat bot. Just click in, enter your details, and then we'll get your requests and we can get the conversation going from there. So thank you once again for being a wonderful, patient audience and an interactive one. Thank you for all those questions. Good day
Thank
and
you.
happy testing.
Thank you.